Simplifying Kubernetes Storage, a beginner's guide to provisioning. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Kubernetes has revolutionized how applications are deployed and managed, making container orchestration more accessible and efficient. However, managing storage in a containerized environment becomes increasingly important as applications evolve. This podcast is designed to help beginners navigate the complexities of Kubernetes storage provisioning, ensuring your applications have the storage they need to function effectively. Introduction to Kubernetes storage provisioning. By design, Kubernetes is stateless, meaning containers within a pod do not retain data once terminated. However, most real-world applications require persistent storage to keep data across restarts, upgrades, or scaling events. Kubernetes storage provisioning provides a way to manage and allocate storage to these stateful applications, ensuring data persistence and availability. The importance of storage management in containerized environments. In a containerized environment, effective storage management is crucial for several reasons. Data persistence ensures critical application data is not lost when containers are restarted or scaled. Scalability. Proper storage management allows your applications to scale without running into bottlenecks related to data storage. Resource optimization. Efficiently allocates storage resources, reducing waste and improving overall system performance. Kubernetes Storage System Overview. Kubernetes provides a robust storage system that integrates with various storage backends. It abstracts the underlying storage infrastructure, allowing developers to focus on their applications without worrying about the details of storage management. Core components of Kubernetes storage. To understand Kubernetes storage provisioning, it's essential to grasp the core components that make up its storage system. Persistent volumes, PVs. These are the building blocks of Kubernetes storage. A PV is a storage piece in the cluster that has been provisioned by an administrator or dynamically created using storage classes. It is independent of any individual pod and can exist beyond a pod's lifecycle. Persistent volume claims, PVCs. A PVC is a user request for storage. PVCs are bound to PVs, bridging the user's storage needs and physical resources. Storage classes, SCs. Storage classes define the classes of storage available in a cluster. They provide a way to describe the different types of storage, for example, SSDs versus HDDs, and allow for dynamic provisioning of PVs. Provisioners and CSI drivers. These are the engines behind storage creation. Provisioners are responsible for dynamically creating storage when requested by PVCs. Container Storage Interface, CSI, drivers are a standardized way to manage Kubernetes storage, making supporting various storage backends easier. Static provisioning, manual allocation of storage resources. Static provisioning involves manually creating and managing persistent volumes. This method is straightforward but requires the administrator to manually manage the storage resources lifecycle. Step-by-step process of static provisioning. Create a persistent volume, PV. Define the PV in a YAML file with specific attributes like storage capacity, access modes, and storage class. Apply the YAML file. Use the kubectl apply command to create the PV in the Kubernetes cluster. Create a persistent volume claim, PVC. Define a PVC that matches the attributes of the PV. Bind PVC to PV. Kubernetes automatically binds the PVC to an available PV that meets the criteria. Advantages and use cases of static provisioning. Fine-grained control. Administrators have complete control over storage allocation. Predictable performance. Since storage is manually provisioned, administrators can ensure that storage performance meets application needs. Use case. Ideal for environments where specific storage needs are well understood and unlikely to change frequently. Dynamic provisioning. Automatic allocation on demand. Dynamic provisioning automates the creation of persistent volumes when a persistent volume claim is made. This more flexible and scalable approach allows Kubernetes to handle storage provisioning based on the defined storage classes. Step-by-step process of dynamic provisioning. Define a storage class, SC. Create a YAML file that defines the storage class, including the provisioner and parameters. Create a persistent volume claim, PVC. In the YAML file, define the PVC and specify the storage class. Automatic PV creation. When the PVC is applied, Kubernetes dynamically creates a PV that meets the criteria and binds it to the PVC. Advantages and use cases of dynamic provisioning. Automation reduces administrative overhead by automating PV creation. Scalability easily scales with the application, automatically provisioning additional storage. Use case. This option is ideal for environments with variable storage needs, such as microservices architectures, where different services may require different types of storage. In-depth, look at dynamic provisioning flow, from user request to PV binding. Dynamic provisioning involves several steps. PVC request. A user creates a PVC, requesting a specific amount of storage with certain attributes. Storage class lookup. Kubernetes checks the specified storage class to determine the appropriate provisioner. PV creation. The provisioner dynamically creates a PV that matches the PVC's requirements. PV binding. Kubernetes binds the newly created PV to the PVC, making it available to the pod that requested it. Static versus dynamic provisioning. Choosing the right approach. The choice between static and dynamic provisioning depends on several factors. Static provisioning. Best for environments with stable, predictable storage needs where administrators want complete control over storage allocation. Dynamic provisioning. Ideal for dynamic environments with fluctuating storage demands, where automation and scalability are priorities. Conclusion. Mastering storage provisioning in Kubernetes. Kubernetes storage provisioning is a powerful feature that allows you to manage storage effectively in a containerized environment. By understanding the core components and provisioning methods, you can ensure that your applications have the storage resources they need to operate smoothly and efficiently. Key takeaways for effective storage management. Understand the components. Familiarize yourself with PVs, PVCs, SCs, and provisioners to manage storage effectively. Choose the right provisioning method. Decide between static and dynamic provisioning based on your environment's needs. Leverage automation. Use dynamic provisioning to automate storage management in scalable environments. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.